We're going to look at example 1, problem F in your section 5.5 notes, the substitution rule for definite intervals. So looking at this, the setup, trying to figure out what u is, this should remind us of the tangent inverse. Okay, so unfortunately we can't take the antiderivative of this the way it is. We need 1 over something squared plus 1. So the first thing we're going to do is take out a 36 from the denominator. Okay, so if I go ahead and pull out a 36 from the denominator, probably best to take that out of the integral. Okay, so when you do that, that makes the 25 divides by 36 when I take it out. And then the nice part is that when 36 divides by 36, we get 1. Okay, so I'm just rewriting at this stage. I'm not changing anything. So I can absolutely multiply the 36 back in. I can get back to the 25. And of course, 1 times 36 is 36. All right, so we're looking more like the tangent inverse. Okay, so one more step to help us out, help us to see what u is. All right, so I said that we need something squared right here. So we can think of 25 as 5 squared, 36 is 6 squared, and of course, we have the x that's squared. So there you go, there's your u, okay? All right, so our u is 5, 6x at that stage. That's what we want to have take the place of u, okay? So if I look at du, I'm gonna get 5, 6 dx. Okay, now we know outside of this, the only thing that's outside of there is dx, okay? So if we clean this up, we need to multiply by the reciprocal, so we get 6/5 du is equal to that dx expression, okay? All right, we're ready for the substitution. So we have the 1 over 36. We're gonna change our limits of integration here in a minute, okay? Substituting in, I have 1 over u squared plus 1. And then this dx, we said was 6/5 du. All right, now this fraction can come out and join this other fraction. So I'm gonna have 1 over 36 times 6/5, so some good reducing happens there. Okay, I still haven't put in my limits of integration quite yet. Okay. All right, so we need to definitely put those limits of integration in. So for our upper limit, we need to go ahead and plug in 6/5 here. So for our upper limit, if I go off to the side here and work that out, I'm gonna get 5, 6 times the 6/5. Okay, nice things happen. So my upper limit is gonna be 1. Okay, for my lower limit, okay, if I plug in, I'm gonna have 5, 6, and the original lower limit was 0. So my new lower limit is now gonna be 0, okay? All right, so we are ready to find the antiderivative here. Okay, so cleaning this up, we're gonna have the fraction out in front is 1/30. Okay, the antiderivative of this is tangent inverse of u, which we're evaluating for our new limits of integration of 0 and 1. All right, so we're gonna have 1/30. Okay, we're gonna have the tangent inverse of 1 minus the tangent inverse of 0. Okay, we need to find both of those values. Those are actually pretty easy to find. Okay, so I'm gonna do the work over here to help you out. So tangent inverse, we know has to be an angle between negative pi over 2 and pi over 2, okay, not including those two quadrantal values. Okay, so if I take the tangent of both sides, I get the tangent of theta equals 1. So I need to ask myself who has an answer of tangent theta equals 1 if I'm looking at the quadrants 1 and 4, okay, from negative pi over 2 to pi over 2, okay? So since it's a positive answer right here, I know I'm in quadrant 1 for my theta, and I know tangent is opposite over adjacent. So when you have this set up, the hypotenuse is the square root of 2, and we have one of our special values. So this triangle, that value, the theta is pi over 4, okay? All right, so we're gonna get 1/30, okay, and we have pi over 4. Okay. All right, if we do a similar thing for tangent inverse of 0, we're actually going to get the quadrantal value of 0, okay, as our angle. All right, so we really comes down to multiplying these out, and when we do that, we end up with pi over 120, and that completes problem F.